Okay, welcome to week 12 maintenance. Here we have a quadratics question and we want to find the values of k for which this equation here has no real roots, which means that our discriminant has to be less than 0. So we plug in our numbers. Now b is minus 4, so we're going to chuck in minus 4, we square it. Minus 4 times a, which is k, times c, which is 8, and that's got to be less than 0. So we get 16 minus 4 minus 32k, sorry. Minus 32k is less than 0. Now we can just move that across, so 16 is less than 32k. And so 1/2 is less than k. Or k is greater than 1/2. Okay, we're defining this equation here. Now I've got to explain why it has an inverse. So what I'm going to do first is I'm actually just going to complete the square. Which I'm going to need for the next part of the question anyway. Now, you'll see why I'm doing this. So when I complete the square, what do I get? Well, I'll get 2 bracket x minus 3 all squared, and then that's plus, what the heck? Oh, that's a negative 18, isn't it? Negative 18 plus 13, so negative 5. So we've got a MP, or a minimum point, at 3, negative 5. That's our turning point. Now, so here's our equation. We've got this is 3, this is negative 5, so we've got something that looks like this, roughly. I don't actually, I'm not going to draw it accurately, but we are defining this from x equals 4, which is here, greater than 4, so we're dealing with this. So why does it have an inverse? Because we've defined it so that it will be that the inverse can be 1-to-1, right? Because if we defined it, say, over here, that's a many-to-1, and when we do an inverse, we'd get 1-to-many, which is not a function. Okay, so now we can write an expression of the inverse function. So I'm just going to take this completed square version that I did just earlier, and the reason I take that is this is when we've got a quadratic and we need to find the inverse of it, this is what we use. Okay, this is how we do it. So we swap our x and y values because that's what an inverse does, and then we're just going to rearrange our formula. So I'm going to get x plus 5 divided by 2 is equal to y minus 3 all squared. Did 2 steps there. I'm going to square root both sides, so I get plus or minus the square root of x plus 5 all over 2 equals y minus 3. That's a 3. Then over here we'll just carry it on. I'm going to say y is equal to 3 plus or minus the square root of x plus 5 over 2. And then we've got to decide when we put it back into the function notation whether we want the positive or whether we want the negative. Now, the positive is always this part, and the negative is always on the other side of the of the turning point. So obviously in this case we want the positive, so it's going to be 3 equals 3 plus the square root of x plus 5 over 2. Okay, now the diagram shows the points A, B, and C lying on a line 2y equals x plus 4. The point A lies on the y-axis and AB equals BC. The line from D, 10 minus 3, to B is perpendicular to AC. We've got to find the coordinates of B and C. Okay. Alright. Well, first of all, we can find the coordinates of A, can't we? So A is on the line 2y equals x plus 4. And we know that since A is actually on the y-axis, we know that x is equal to 0. So in that case, 2y would be equal to 4, so y would be equal to 2. So we know the coordinates of A is 0, 2. Now that we know that, we're going to find the gradient of the line DB. Now, since AC has a gradient of, let's have a look. If we were to rewrite this, we'd say y is equal to half x plus 2. I'm just dividing everything by 2. Since AC gradient is 1/2, therefore dB gradient is equal to -2. So now I'm going to find an equation for line BD. So equation of BD is going to be y minus y1, so I'm using these here, equals m, which is our gradient, into x minus x1. Now we will get this, and we're just going to subtract the 3 from both sides, and we get that. So now we've got two equations. We've got an equation here, and we've got this equation here, and we want to find out where they meet, which is at B. Okay, so let's see. I'm going to push this down because I'm going to need some more room here. Okay, so let's make those two equations equal. See where they meet. So we have -2x plus 17 is equal to 1/2 x plus 2. I'm going to multiply both sides by 2 just to get rid of that annoying half. I'm going to bring the x's over to the right hand side, and then I can see that x is equal to 6. And therefore y is equal to, now to find my y value I can just chuck it in here. So -2 times 6 plus 17, positive 5. Okay, so the coordinates of B, therefore the coordinates of B, 6, 5. Now that we know that this is 6, 5, we can work out where C is, because if you look, this is a midpoint, so we've gone across 6 and up 3, right? And then we're going to do the same again, across 6 and up 3 to get there, because it's a midpoint. So 6, 5, across 6 we're going to get 12, 8. And that would be our answer. Whoops, why is the 8 up there? It's flying up high. Okay, there we go, 12, 8. And that would be the coordinates of C. Okay, so circular measure. So we have a sector AOB of a circle centered O with a radius of 5 and a sector angle of pi over 3 radians. That line AP and BP are tangents to the circle, and we've got to find the exact length of AP. Okay, well, okay, here's the thing. If we just join up here to here, we know that this is a 90-degree angle because that's a tangent. And we want to find this length here, which is x, and we can use trigonometry because this angle here is going to be pi over 6. So that would be opposite over adjacent, so it should be, I think, 10 pi over 6 is equal to the unknown over the adjacent, which is 5, and so x is equal to, now what does this work out to be? 10 pi over 6, which is square root 3 over 3, times that by 5, so we get or square root 5 square root 3 over 3 length of AP. Find the exact area of the shaded region. Okay, so what we're going to do for the shaded region is we're going to find the area of this triangle and double it, right? So, and then we're going to subtract this sector here, okay? So the area of the triangle is half, I mean there's two of them, right? There's two of those triangles. Is half r squared, half base times height, we can do that. Half 5 times the height, which was what we found in the previous question, 5 square root 3 over 3, and we've got two of those. And then we're going to subtract from them the area of the sector, which is half r squared theta, half times 5 squared times pi over 3. And what does this give us is our answer. So we should get 5 times 5 square root 3 over 3 minus 0.5 times 25 times pi over 3. I'm getting an answer of oh right, I've got to do an exact answer. Oh poos. Alright, let me just give ourselves a bit of room by moving this over here for now. Okay, so let's go to the next line. So we end up with 25 square root 3 over 3, because the 2 times the half cancels out. Then I'm going to take away half, and we end up with 25 pi over 6, I think. And then to factorize that, maybe we'll just take out 1/3 maybe, 25 thirds. And then we get square root 3 minus pi over 2. And I think that will be sufficient for us. Okie dokie, so we've got to solve another trigonometric equation. This looks like a quadratic type 1, so we're going to go tan x minus 1 bracket tan x plus 3. Yep, equals to 0. And so tan x is equal to 1 or minus 3. So x is equal to the inverse of tan of 1, which is, now what are we're in degrees, so make sure your calculator is set to degrees for this one. So that's 45. And the other one is, our other principal value we want is this one, and we have a negative 3. So pop that in there and we get 71.6. And now we just need to consider our tan graph. Okay, so there's 360, 180, 90 is here, and 270 is here. I haven't drawn that very well at all, have I? But you get the general idea. So 45 and 71, so you need just to add 180 to each of those to get the other two answers. So I've got a 251. Whoops. A 251.6, and 45 plus 180 is 225. So I need a 225 here as well. And I think that's all that we need. I think that's right. Just do that, just check that there. Oh, sorry, I made a mistake there. I didn't do a minus 3, I did a positive 3. Which yeah, I was just questioning these values here because we don't have something up here, do we? We've got something down here, so I'll just correct that in red. So I've got a minus 3, and I get a negative 71. So I want to add 180 and 180. So let's get rid of those. That gives me 108. Yeah, that's better. So I get 108 here, 0.4, and then this one here is going to be 288.4. Yeah, sorry about that, guys. Okay, because obviously we want negative 3, and negative 3 is down here. It's not up here. That I was doing a positive 3. Okay, anyway. Last one for which it's an increasing function. Okay, so an increasing function is where the gradient is positive. So I just want to find, I just want to differentiate. So f prime x is equal to 6x squared minus 30x plus 24. So I've just differentiated there. And I want to know, where is this an increasing function? So in other words, where is the gradient greater than 0? So what I'm going to do is I'm just going to divide that whole thing by 6, set it equal to 0, and then I can factorize, I think, to draw my diagram. Yeah. Okay. So you can see that if we were to sketch this, we've got a root at 1 and a root at 4. And where is it greater than 0? Well, you can see that it's above 0 here and here. So that's where the gradient is positive, which means where it's an increasing function. So it's an increasing function when x is less than 1, or when x is greater than 4. And that brings us to a close of this week's maintenance. I hope that's been helpful and makes sense to you. If I've made any errors, of course, let me know. It happens. Yeah, have a good week. See you later.